This is the video on 2-4. What is an identity? An identity is an equation that is true for every possible value of the variable. So if I say 5x plus 2 equals 5x plus 2, that is called an identity because it does not matter what x is, this equation is going to be true. Both sides of the equation are equal to each other. So example number 1, solving an equation with variables on both sides. The goal remains the same. I want to get x by itself on one side of the equation with a coefficient of 1. So how am I going to do that? Well, I need to get the x's together. And so what I'm going to do is I'm going to subtract 2x from both sides, and that will give me 3x plus 2 equals 14. And why did I pick subtraction? Because this is a positive 2x. I have a positive 2x, so I'm going to subtract 2x from both sides. And you could have started by subtracting 5x from both sides. That's fine, that would work. But I want to train you to work smarter, not harder. And so I want you to try to avoid negative answers if at all possible. So that's why I picked subtracting 2x rather than subtracting 5x. But either way, you should get the same answer if you do your math right. And so now, what do? I want to get everything away from the variable, and so I'm going to leave the term that has the variable in it for last. So I'm going to subtract 2 from both sides, and that gives me 3x equals 12. And then what do? I have 3x equals 12. I'm going to divide both sides by 3, and that gives me x equals 4. And then again, to check your answer, you just plug it back in. And you're asking yourself, well, when x is 4, is this equation true? Okay, so go ahead and hit pause and work out this on your own. Okay, so let me work it out for you. I want to go ahead and start by subtracting 4x from both sides, because from looking at it, I would know that would give me a positive 3x, and I just think that's a lot easier to work with. And now what am I going to do? I'm going to subtract 2 from both sides. And look at this. I have negative 10 minus 2. Keep, change, change. So negative 10 minus 2 is the same thing as saying negative 10 plus negative 2. Do the keep, change, change so you don't make a computation error. And so then my answer is negative 4. If you started by subtracting 7x from both sides, that should get you the same answer. Okay, solving an equation with grouping symbols. Again, my thinking has not changed. Before I start isolating my variable, I have to look at each side of the equation, and I have to simplify each side of the equation. Before I start actually going through the process of isolating my variable, I have to simplify each side of the equation. So what do I need to do here? I need to distribute a 2, and on this side, I need to distribute a 3. And when I do so, this is what I get, and now that I have simplified both sides of the equation, now I can go ahead and start solving for my variable. So I want to get my variable together, and so I'm going to go ahead and I want to start by subtracting 3x from both sides, just because I think that's easier than subtracting 10x, but it does not matter. And now what I'm going to do is I'm going to bring it over here so you can see it better. I'm going to go ahead and add 2 to both sides. And now I'm going to divide both sides by 7. Okay, so go ahead and hit pause and work out these on your own. Okay, let me work them out for you. I want to simplify this entire side and I want to simplify this entire side. And so how am I going to do it? I'm going to distribute out of 4 here, and here I'm going to distribute out of 2. Now that I've simplified both sides, I want to get my variables together. I think it's going to be easier to subtract 2y from both sides rather than subtract 8y from both sides. And now I'm going to go ahead and subtract 4 from both sides. Look at this. I want to look at this and I want to say keep, change, change. So that ends up being negative 30. I'm going to divide both sides by 6. And here's my answer. If you have any questions, let me know. Okay, I want to simplify this side, so I'm going to distribute out of 7. And then I want to simplify this side, so I'm going to distribute out of 3. Now look at this. You can solve this by subtracting 3a from both sides, or you can solve this by adding 7a to both sides. It doesn't matter. Do whichever one you think is going to be easiest for you. I think personally adding 7a to both sides is going to be easier because that will give me a negative, or excuse me, because that will give me a positive answer there. I want to try to avoid negatives if at all possible. If you didn't do it that way, again, you should still get the same answer. And you will learn which way is the easiest way over time. I promise. You'll be able to spot it eventually. So now what am I going to do? I'm going to add 12 to both sides. And then I'm going to divide both sides by 10. And so then a is going to be 4. If you got either one of these wrong, watch what I did and then do it again. Okay, and finally, last example. Identities and equations with no solutions. Remember what an identity is. It's an equation that's true for all possible values of the variable. And so let me go ahead and simplify this side before I start getting my variable isolated. So I'm going to distribute the 2, and when I do so, I get 10x plus 12 equals 10x plus 12. Well, wait a second. I can stop right there. Both sides of these equations are equal. So this is what we call an identity. This equation is going to be true for all possible values of the variable. Now, if you're going along and you're not really paying attention to what you're doing, and you don't catch it there, watch what happens. What happens if I wasn't paying attention and I said, well, let me combine my variables, or, excuse me, you're using inverse operations to get your variables together on the same side. So I'm going to subtract 10x from both sides, and look at what happens. My variable disappears, and I'm left with 12 equals 12. And that's how you know it's an identity. But on this one here, watch what happens. I'm going to go ahead, my process remains the same. I'm going to simplify everything that I can that's on one side of the equality symbol. So that means I'm going to combine a negative 3m with a 12m. And when I do so, I get 9m. I have 9m minus 4 equals 9m plus 5. Is there any possible value of the variable that will ever make this equation true? It doesn't matter what 9m ends up being. There's no way these equations would ever be true. You can't take a number, because 9 times m will end up being a number of some sort. I can't take any number and subtract 4, and then take that exact same number and add 5, and have those equations be equal. That will never happen. So there's no solution to this. And if you're going along and not really paying attention to what you're doing, and you get 9m minus 4 equals 9m plus 5, and if you don't see it, if you don't really see it, but you're going along and you're like, all right, well, let me go ahead and get my variables together. So I'm going to subtract 9 from both sides. And what happens? My variables disappear. And I'm left with this, which is clearly not true, and so there's no solution. So whenever you're going along and your variables disappear, you either have an identity or a no solution. And you can tell by whether these are true or not. This would be an identity, and since this is not true, you would say no solution. Okay, so go ahead and solve these two and tell me whether it's an identity or no solution. Okay, and let me solve them for you. I'm going to go ahead and distribute out the 3. And I have 12b minus 6 equals negative 6 plus b. Let me go ahead and switch the order of these terms just so I can see it better. I have a positive 12b and a negative 6. And what do I have? 12b minus 6 equals 12b minus 6. So this is an identity. But I want to make sure you see what I did. I just switched the order of these terms, which you can do as long as you keep the same sign. I have a negative 6 combined with a 12b, and here I have the same situation. I have a negative 6 combined with a positive 12b. I just switched the order. Because remember, this is the same thing as saying 12b plus negative 6. So do you see how this and this are the same thing? They're all three of these are the exact same thing. You have to be comfortable switching the order of those terms and to know how to do it so you can better see them sometimes. Okay, finally, last example, I'm going to go ahead and distribute out this negative 1. I'm going to go ahead and switch the order of these terms so I can better see it, which would be 2x minus 3. So now wait a second. 2x plus 7 equals 2x minus 3. That would never happen. And so you would say there's no solution. And again, do you see how I switched the order of these terms? But it's the same thing. A positive 2x connected to a negative 3 is the same thing as a positive 2x connected to a negative 3. Okay, go ahead and hit stop and do your homework and let me know if you have any questions.